Welcome to Study Loop.
So in this question, we have first part in which we have asked to determine the direction of electric field. So in the question given, the magnetic field is in inward direction, that is cross, and it is decreasing with the time. So the flux will also decrease. So from the Lenz's law, we know that the induced current will oppose the changes. So the induced magnetic field will also in the cross direction. Hence, the induced current I induced will be clockwise, and the induced current is in the direction of electric field, or we can say that the electric field is in the direction of induced current. So we can say that the electric field will be in the direction of clockwise. Electric field will be in clockwise direction. Clockwise direction. Okay, so this will be the answer for the first part A. Electric field will be in the clockwise direction. So moving to the next part is to determine the magnitude of electric field. So from the theory of electromagnetic induction, we know that E multiplied by 2 pi r is equals to pi r square dV by dt magnitude. This is electric flux and this is magnetic flux, so both flux will be equal. So from here electric field can be written as 1 by 2 r dV by dt. So by putting values, 1 by 2 r is 0.100 meter multiplied by dV by dt is 0.0350 Tesla per second. So from here the magnitude of electric field will be equals to 1.75 multiplied by 10 to the power minus 3 volt per meter. This will be the electric field induced in the given coil. Okay, so this is the answer for the second part. So moving to the next part, the part C is to identify the induced EMF. So the induced EMF epsilon can be written as closed integral of E dot dl. E dot dl. So from here we can write E multiplied by 2 pi r. So putting values, epsilon equals to E. E is 1.75 multiplied by 10 to the power minus 3 multiplied by 2. Pi is 3.14 or 22 by 7 multiplied by r. R is 0.100 meter. 0.100 meter. So after solving it, the magnitude of induced EMF will comes out to be 1.100 into 10 to the power minus 3 volt. So the induced current will be equals to I equals to E by R, and R is the resistance of the coil, which is given as 4 ohm. So 1.100 multiplied by 10 to the power minus 3 divided by 4. So after solving it, we can identify the magnitude of induced current as 2.75 multiplied by 10 to the power minus 4 ampere. This is the answer for the second problem, in which we are asked to calculate the magnitude of induced current. So moving to the next part, D, in which we have to identify the induced electric field between A and B. So induced electric field between A and B will be equals to E multiplied by pi r, where pi r is the distance between 2 points, that is A and B. So putting values, EMF will be equals to 1.75 multiplied by 10 to the power minus 3. This is the value of electric field, and pi, and r is 1.0.100 meter. Okay, so after solving it, EMF E will be equals to 5.50 multiplied by 10 to the power minus 4 volt. This is the induced EMF between points A and C. Okay, A and B, sorry. So this is the answer for the part D. So now moving to the next part. In the next part, we have to calculate E, part E. In this part, we have to calculate the induced EMF after ring is cut. Ring is cut from any point. So after cutting the ring, the induced EMF will be equals to the EMF obtained in the part C, and which is equals to 1.10 multiplied by 10 to the power minus 3 volt. Okay, so this will be the answer for the last part. 1.10 multiplied by 10 to the power minus 3